All right, so we're going to go ahead and jump into this. Super excited to get started today. Like I said, we're going to learn trigonometry today first, and then we're going to do the embarrassing part of the lesson because everybody thinks they either don't know trig or they know it really well, and you either will or you won't. But the part that's going to be embarrassing today is when we do the middle school math section. And the amount of middle school math that you guys have lost is going to make you feel sad about yourselves. And that's okay, because we're going to clean it up. About 25% of the test is specifically middle school math. But what most students don't realize is that almost every single question on the ACT incorporates some aspect of pre-algebra or algebra 1 into the question. So if you do not have these foundations down, you are missing a ton of questions that you absolutely can get correct, even though you're getting every other step correct. You're missing that one middle school math step. Another thing that the ACT loves to do is to make it so you can't do questions with your calculator by substituting in letters instead of numbers. So they're going to take middle school math concepts that you could very easily do if you could do it with your calculator, and they're going to substitute in numbers. And you guys have often forgotten the steps that you're supposed to use to be able to do that. So we're going to get that middle school math cleaned up this week, and we're going to start that process at the end of class today. And then we're going to end talking about some of the upcoming events. We have a mock ACT coming up in a couple of weeks on November 30th. If you guys have not signed up for that, I'm going to encourage you guys to do that. This is the last one for the December ACT. Hopefully all of you are taking the December ACT. This is when your math score will be the absolute highest of all of the program. And so we want to make sure we get that super score as high as we can by taking this December ACT. And the best way to get that December ACT score as high as possible is getting the jitters out first by taking that mock ACT on November 30th. And as students, you guys all get to do those for free. So please remember to put in the discount code STUDENT. I'm going to remind you of this again at the end of class. Yeah. And last but not least, we're going to end today with about 10 minutes of looking over what this week is going to look like. So please don't start putting your stuff away when we get done with the middle school math section because we've still got about 10 more minutes at that point to just make sure everybody understands the flow of this week, make it as seamless as possible. All right. So with that being said, please go ahead and pull out a couple of sheets of paper and yeah, something to write with. All right, guys. So as far as where I want to start off is by just giving you guys some belief again and getting you guys excited about what is possible. So a lot of students realize that it is unlikely that they're going to make it on the lifetime wall of greats. The lifetime wall of greats is the top 20 students who have ever done our program in those sections. But every year we do a superstar book just for students from that year. And 70% of students will make it in the top 20 in at least one of the categories. So it is very likely that you are going to find yourself in the superstar book for that year, and just being able to remember your accomplishment for that year. And yeah, if that type of thing motivates you, then use it. But for now, we're going to go ahead and look at some of the 2022 Superstars, we had a glitch with 2023 and haven't been able to get that up on the website yet. But you should still recognize some of our 2022 students and what they were able to achieve on this math. Yeah, we have Elizabeth Knoll from Catholic, 6-point increase from a 25 to a 31. Richard Hong from Farragut, 6-point increase, 29 to a 35. Duncan Green from Career Magnet, 7-point increase from a 24 to a 31. Maddie Boole from Berean, 8-point increase, 18 to a 26. We got Annie Hodge from West, 8-point increase, 21 to a 29. John Tome from Webb, 8-point increase, 23 to a 31. Brian Utomo from Bearden, 9-point increase, 25 to a 34. Scott Dunlap from Bearden, 9-point increase, 27 to a perfect 36. We got Morgan Parrish from Farragut, 10-point increase, 17 to a 27. Naja Alfar from HVA, 11-point increase, 16 to a 27. I'm going to tell you guys a story about her here in just a couple minutes. Connor Beck from HVA, 11-point increase, 18 to a 29. And the biggest increase on the math in 2022 was Mr. Raheem Rashid from Farragut, 11-point increase from a 19 to a 30. All right. So to tell you guys the story about Naja Alfar, she was the hardest working student in her cohort, increased more points on practice tests than any other student in her cohort, skipped the midway ACT in her program, and ended up taking the ACT for the first time at the end of the program, had a 0-point increase. 0-point increase. And we know that she was being honest on all of her practice tests at home. But what we want to emphasize is that the longer you wait to take the ACT after you begin the program, the more and more that pressure builds. And that first test for everybody, is just about getting the jitters out. It's just about getting the jitters out. That's why we want you guys to take the midway test so much, because you are setting yourself up for disappointment if you guys skip that midway test. If you can't take it, you can't take it, but you need to get yourself mentally prepared that you're not probably going to do very well on that test that you take 3 months after you started the program, and you're going to need to take it again. The very next test, 7-point composite increase, the very next test. But it is highly likely that you're going to bomb your very first test that you take. And that's another reason we want you guys taking the mock ACTs, because that is another preventative mechanism to help you work out some of your jitters after you have begun prep. You will experience way more pressure after you begin prep than before it. So you got to find a way to get that out of your system. All right. So with that being said, now we're going to go ahead and jump into the trigonometry. All right. So if you will go ahead and open up your schedule, and on your schedule, you are going to see the section where it says trig. And I want you guys to go ahead and click on that trig section there. Let everybody get there. Yeah, I will have it up on the screen, but it will certainly be best for you to be able to move things around on your own screen. All right. So, yes, the purpose of this, we choose trig because it's the one that the most students have never been exposed to. And our goal today is to help you see that you do not need to have ever had the math to be able to learn the math on the ACT. All right. You do not need to have had stats. You do not need to have had geometry. You do not need to have had trigonometry. You certainly don't need to have calculus because no calculus is on the ACT. They have 2 questions that sometimes look like calculus, but they are not calculus, like vector questions, and polar coordinate questions, which you can learn how to do in a matter of minutes. Yes, so that is our goal for today, is to show you guys that math that seems impossible to you can be learned instantly. Our goal is that you will leave here today being like, there is no way it is that easy. And it really, really is that easy. Many of you are going to be sitting here like, I'm not getting it. I'm not getting it. I'm not getting it. And I just encourage you, please do not let yourself stay there. Every question of today, every single student, every single middle school student with no background in trigonometry or anything else can get this right now while we're standing up here. It just might take a second to click, but we're going to keep working on it until it does. And even if you miss parts of it, it's okay, because you don't have to retain the previous stuff to be able to get the next stuff, but it does help. All right. So please try to keep up, and please ask questions if you guys are getting confused. You guys will also be able to ask these questions of your coaches later. All right. So anybody having a hard time finding the trig lesson and being able to get that open? Everybody got that open? All right, great. All right, so we're going to go ahead and do number 1. I want everybody to try to answer question number 1, and we're not expecting you to. I just want you to know that you don't know, and then see how fast you can go from not knowing to be able to get these right every single time. All right, Elizabeth, do you know the answer to question number 1, or you need some help? No. Don't do shot in the dark. I don't like shot in the darks. If you guys don't know the answer, just say, I don't know. It's totally okay to say, I don't know. And I would prefer, if you guys don't know, don't guess. That's great. That's what I want to hear. And that's why we're doing this. All right. So the amplitude, when you're looking at a trigonometric function, is the number out front. So what is the number out front there, Elizabeth? So what is the amplitude? 3. Is that beyond your ability as a human to be able to do? This is a real question on the ACT. That is a real question on the ACT, because they know that most students aren't going to know what an amplitude is. And so they're just testing to see for those students who do. That's it. And they're going to choose some of the easiest stuff that they could from these harder maths. So don't think because you haven't had that math that you can't watch that quantum ACT prep video and learn how to do it and then be able to do it forever. This is easy stuff. You don't even need to know what an amplitude is. All right. So, all right, everybody try question number 2. Everybody try question number 2. All right, Ari, any luck on question number 2, or do you need some help? All right, so this is what I love. I love helping students go from not knowing how to do something to being able to get it right every time. All right, so if you're looking at a graph, the amplitude is just the distance from the middle to the top. You could also go from the middle to the bottom, which is going to be the same distance, but it's just from the middle to the top. So what is the distance from the middle to the top there, Ari? Or is it still a little bit foggy for you? Well, so it goes up to 2. Do you see that the line there is 2? All right, but you know, if you were doing it at an angle, it might be 3, but it's just literally the distance, a straight line distance from the middle to the top. So what is the straight line distance from the middle to the top? 2. It's 2. So is that beyond your ability as a human to be able to do? No. You can absolutely get these correct every single time now. And this is a real question on the ACT. Real question on the ACT. All right. So please, no, you do not need to know trigonometry to be able to get these trigonometry questions correct. You just need to learn how to do those trigonometry questions. That's it. And that's what we're doing with Quantum ACT Prep. Right? All right. So this one's just a bit of memorization. Doesn't show up perfect on the screen right here, but the one on top is the A graph. The one on bottom is the B graph. All right. So you just have to memorize these. And I want you guys to see if you can identify them. I mean, you got a 50-50 shot, but I don't want you to guess. I don't want you to guess. If you don't know, just say, I don't know if I call on you. But yeah, try to figure out which one is sine and which one is cosine of the parent, okay? Sine of x and cosine of x. Which one is sine of x? Which one is cosine of x? If you don't know, I'm calling you. Say, I don't know. All right, Olivia at home, do you know which one is sine of x and which one is cosine of x, or do you need some help?
Is the first one sine of x and the second one cosine of x?
It is. All right. So the only way to really do this, or the best way to do this, is just to memorize it. So this is just something you're going to have to memorize. All right. And the second one here is cosine of x. I'll tell you how I have memorized this. You don't have to use this. You can use whatever you want. But somebody taught me this along the way. They had a picture of a snowboarder on top of the mountain coming down the mountain saying cowabunga. And cowabunga, I remember with cosine. So this is like a mountain. If that helps you, you can use that. If not, don't worry about it. Use whatever system works for you. But sine of x is going to start at 0 and go up. Cosine of x is going to start at the top of the mountain and go down. And so that is what we need to know. So we're going to do different transformations of these two graphs. So you need to memorize these graphs, or at least, know that this one is cosine of x, this one is sine of x, however you do that. Yeah, so we'll start working on this together. Now, the transformations that we are about to do, they apply to all geometry, all coordinate geometry. So if you memorize these transformations, you'll be able to do the transformations of a ton of different math problems on the ACT. So don't feel like this only applies to trig. It absolutely applies to all coordinate geometry. All right. So what I want you to tell me if I call on you is what transformation is happening based on what we have added to sine of x. So this is sine of x minus 4. So I want you to tell me when we subtract 4 from sine of x, what is going to happen to our sine of x graph? All right, it's okay if you don't know the answer. You're all going to learn it, and you're all going to be able to do it. And remember, it applies to all of math. Applies to all of math. All right? So everybody try to answer that for number 4. What transformation occurs to our sine of x graph if we subtract 4 from it? Hudson Harris, can you tell me what transformation occurs on number 4 there?
Down 4 units.
Say it again.
Down 4 units.
Down 4 units. All right. So it's going to take our sine of x graph here, and it's just going to move everything down 4 units. Okay. So it's just going to scooch it down every one of the points. You're just taking the whole thing and moving it down 4. All right. So Hudson, I'm going to ask you a little bit of a harder question. All right. So right here, it crosses the y-axis at 0. So when we do the transformation, where is it going to cross the y-axis?
It should be I'm guessing 2.
Not 2. Try it again.
2.
So how much are we moving the entire graph down?
4 units.
4 units. So if it's at 0 right now, where is it going to be when we move it down 4 units?
-4.
-4. Does that make sense?
Yeah, it does.
And this is going to be important when we do our a later section. But it's just taking every one of those points, and it just makes the y coordinate down 4 lower than it was prior. Does that make sense? All right. So great work. Yeah. And So we'll do one more, and then I'll teach you guys a little bit about how to remember it. So everybody try number 5. This one's a little bit trickier. Everybody try number 5. What transformation is occurring if we add 2 to the x? If we changed cosine of x to cosine of x plus 2, what transformation is occurring? All right, MJ Brooks, can you tell me what transformation is occurring, or you need some help?
Does it move to the left too?
All right, good job. Yes. So most students want to move it to the right too, because you're adding 2 to it. But the funny thing is, when it's in those parentheses, you're going to do the opposite of what you would think. So this is one of the hardest ones, and that ain't that hard. It's just you got to remember, if you're adding 2, it moves it to the left 2. It takes this entire graph here, and it switches it to the left 2. So everybody try to do this one. Right here, it's crossing the x-axis, or the y-axis at 0, 1. So what is the x component going to be when we do that transformation? What is the x component of that dot going to be when we move it, when we do this transformation? So MJ, what is that x component going to be of where it's crossing the y-axis right now?
-2?
Yeah, -2. So right here it's 0. So we're just going to move it back 2, and it's going to be -2. If that's not clicking for you yet, it's okay. It's going to click. I'm going to keep asking you guys what the x and y values are after the transformations. And you're just going to do, if you are subtracting 2, you're adding 2, you're just going to take that value and add 2 to it, subtract 2 to it from it, whatever you're doing. But all that to say, if it is outside of the parentheses, it tells you if it's going up or down. If it's inside of the parentheses, it's telling you if it's moving left or right. All right, the left or right is going to be different than you think. If you're adding it, it's going to go to the left. If you're subtracting it, it's going to go to the right. That's inside of the parentheses. All right, so now we're going to do both. All right, so everybody go ahead and try number 6. Try to figure out what transformation occurs to our cosine graph on number 6. What transformation occurs to our cosine graph on number 6? All right, Ava, what is happening on number 6, or do you need some help? Yep, it's going to take our cosine graph. It's going to go right 1 and up 3. Right 1, up 3. Right 1, up 3. Because this tells us left or right. This tells us up or down. And so that's the transformation. A lot of students are plugging these into their calculator to figure out the answer. And I can just tell you, if you are ever plugging anything more than addition, subtraction, multiplication, division, that type of stuff, if you're ever trying to use the graphing function on your graphing calculator on the ACT, you are getting tricked. It is never, never, never the fastest way. And there is always a trick like this that they're trying to see that you know. And it's knowing these tricks that is the only way that you're going to be able to finish the math section of the ACT. You're never going to learn all of the tricks, but you're just trying to learn more and more of the tricks to save up enough time to use on the questions that you don't know how to do. All right? Great work. Great work. All right. So, yes. All right. Everybody try number 7. Everybody try number 7. All right, Brody Groover, what transformation is occurring on number 7 here?
It is left 3 and down 5.
Left 3, down 5. Great job. Left 3, down 5. All right, so this is for everybody. Everybody try to answer this question I'm about to ask Brody, but I want all of you to try to answer it. So what is the coordinate of the origin? All right, if we're moving the origin, so right now it's 0, 0. After we do the transformation on number 7, what is the xy value of the origin there? What does it move to? But try to figure it out first before I ask Brody to solve it. All right, Brody, can you tell me what the xy value is of the origin, or you need some help?
Is it -3, -5?
It is -3, -5. Yes. All right. It's going to take that origin and it's going to move it to the left 3, down 5, which gives it an x value of -3 and a y value of -5. It's going to be right there. All right. So that's still not clicking. It's okay. Just keep working on it. It's going to come. It's going to come. All right, everybody, try number 8. Try number 8. What transformation do you think is happening on number 8? All right, Miguel, do you happen to know the answer to number 8, or do you need some help? It is going to reflect across which axis? X or Y? It reflects across the x-axis. All right, so reflects, it's just going to be the mirror image. All right, so what was underneath of the x-axis is going to be above, and what was below it, or what was below is going to be above, and what was above is going to be below. So it's just going to reflect. All right, so everything is going to be the opposite direction as what it was. So if you have the negative out front, it's going to reflect across the x-axis. If you have the negative inside of the parentheses, it's going to reflect across the y-axis, which this would just be identical. If you reflected across the y-axis, nothing would actually change. Yes, if we reflected across the x-axis by making it negative, it's going to be the mirror image and reflect like that. All right, great work. So these transformations are the same regardless of what math we are doing. And I hope you guys get to see more and more of that as we progress. All right, so now all right, I'm not going to go into the other stuff on there. We're going to move on to domain and range. All right, so I want everybody to try to answer number 13. Everybody try to answer number 13. All right, Gage, any luck on answering number 13, or you need some help?
Would it be all real numbers?
It is. All right. So the answer to what is the domain of all trig functions is all real numbers. All right. So if it's not constricted in some way, all real numbers are, the domain is essentially the x value. All right. So it's just saying it's going to go forever that way and forever that way. So every single number from all the way down the x that way, all the way down the x that way is going to be an answer. And so all the domain of all trig functions is all real numbers. If you know this, you can get some of the ACT questions correct. That's it. You just need to know that. Most students don't know that. So if you know that, all real numbers, easy points on the ACT when those pop up. All right, so the domain is right to left. The range is going to be down to up. Yes, everybody try to figure out what is the range of the parent sine and cosine functions. What is the range of the parent sine and cosine functions? What is the range? If you don't know the answer, it's totally okay. What is the range of the parent sine and cosine functions? All right, Cameron, any chance you know the range of the parent sine and cosine function, or you need some help?
I need some help.
All right. So the range of the parent sine and cosine function, it's going to go from -1 to +1. All right. It's just going to keep bouncing up and down every time that it hits 1. So here's like a function. All right. So we got 1 and -1. All right. It's just going to keep bouncing up and down. Every time it hits it, it's going to bounce, goes until it hits 1, -1, 1, -1. It just keeps bouncing forever. So it's never going to go higher than +1. It's never going to go lower than -1. It's just going to keep bouncing. Therefore, the range, which means the lowest y value that you're going to see to the highest y value that you're going to see of a parent of a sine of x or a cosine of x, is going to be -1 to 1. So, Cameron, is that beyond your ability to be able to memorize?
No, sir.
Yeah, absolutely. All of you can do this. It just takes a little bit of drilling it to get it into your long-term memory. All right. So with that being said, we're going to find the domain and range of the following functions. And a lot of students get discouraged when we first start this because it doesn't click right away. But I want to encourage you. We're going to do this step by step. And please fight until it clicks. Because when you see it, you're never going to unsee it. It's just got to click for you at first. All right. So where I want us to start, I want you to tell me the domain and range of the following functions. But we're going to make it easier at first. All right. So for number 15, I'm going to cross off the second part. And I want everybody to find the domain and range of these, of number 15, but without the second part. So we're just finding the domain of range of cosine of x. All right, so everybody write it down on your scrap sheet of paper that you're using for your notes. Probably best not your notes, on your scrap sheet of paper. What do you think is the domain and range of cosine of x? There's the domain and range of the cosine of x. All right, Lane, do you know the domain of cosine of x? All real numbers, perfect. And do you know the range of cosine of x? All right, so you're a little bit off. You said -3 with a hard bracket to -1 with a hard bracket. It's actually just going to be -1 to +1. -1 to +1. So because it's the parent, it's just going to go down to 1, up to 1, down to 1, up to 1. And as a general rule, it's always going to go down the same amount that it's going to go up. Does that make sense? So yeah, so down to 1, up to 1, down to 1, up to 1. All right. So you might have been answering it with that part there. But yeah, I was trying to remove that part just so that we're all on the same page. If it was just cosine of x, what would it be? All right. So it's going to be all real numbers for the domain either way. Yes, so if it's just cosine of x, it's going to be -1 to 1. So now I want everybody to do that transformation. That transformation is going to take this down 2. All right, it's going to take everything that we see down 2. So I want everybody to figure out, we already know the domain is going to stay all real numbers. So I want everybody to find the range. What is the new range going to be? What is the new range going to be? And it's totally okay if you're not getting this. Totally okay if you're not getting this. It takes a while to click. All right, Alex, any luck on this one, or you need some help? -3 to -1. -3 to -1. So all that he's doing is taking what the range was and subtracting 2 from both numbers. So he took -1 and subtracted 2 from it to get -3. And he took +1 and subtracted 2 from it to get -1. You're just taking what it was and you're subtracting 2 from every number in that system. And that's all that we're doing. That's all that we're doing. All right. It's a great, great job. All right. So now we're going to take this piece by piece here. All right. So I'm crossing off everything after the 2 sign. Crossing off everything after the 2 sign. All right, we're going to go back first. I'm going to make sure you remember what we learned prior. It's okay if you've already forgotten it, but I want everybody to try it. So what is the amplitude of number 16? What is the amplitude of number 16 if I cross off what comes after? What is the amplitude of number 16? Elizabeth, what's our amplitude? 2. All right, so what does that mean? How high is this going to go? Up 2. And how low is it going to go? Down 2. All right, it's always going to go up and down the same amount. So with that in mind, knowing it's going to go up 2, down 2, all right, I want everybody to try to figure out the range. The domain, remember, is going to be all real numbers. So what is the range going to be if we're just looking at 2 sine? Okay, 2 sine of x. All right, what's the domain, or what's the range going to be if we're just looking at 2 sine of x? All right, David, what did you come up with for the range of 2 sine of x? -2 to 2. All right, so it's going to go down to 2, up to 2. All right, and so that is our range if we just have 2 sine of x. Now we're going to include the rest of it. All right, so I want everybody to try to figure out the range of this new one. All right, and I'm going to tell you that the 0.4 has no impact on it. All right, if you multiply the x, it's not going to impact the range in any way. So you can, that number is just there to confuse you. All right, so the only thing that's going to impact it is this +1, and you guys can do this. Just think, what is our new range going to be? What is our new range going to be? All right, Jacob, what is our new range going to be, or do you need some help? -1 to 3. So all that he did, he just took the -2 and added 1 to it to get -1. He took the +2 and added 1 to it to get 3, and that's our new range. All right, so if it helps you to break it down into steps, then break it down into steps. All right, break it down into steps. If you want to visualize it, it's just going to take the entire graph that's going up 2, down 2, up 2, down 2. It's going to move the whole thing up 1. So it's going up to 3, down to -1, up to 3, down to -1. But you guys can all do this. All right, so now we're going to leave it all together. I want everybody to try number 17. See if you can figure out the range on number 17. The domain, again, is going to be all real numbers. So everybody try to figure out what is the range on number 17. So we're doing the whole thing here. So 3 sine of x plus 4. What is our range going to be? You can still do it in steps if that helps you. But what is our range going to be? All right, Christian Salas, any luck on this one, or you need some help? It is. Well done. All right, so he got the range as 1 to 7. If you were doing it without the 4, it would be -3 to 3. But with the 4, we're just going to add 4 to both of those numbers. Oops. Yeah, -3 to 3. So we're going to add 4 to both those numbers. -3 plus 4 is going to be 1. 3 plus 4 is going to be 7. Great job, Christian. All right. So Yes. All right. So we're not going to go any further on that. That is one of the hardest things in the lesson for most students. And if you didn't get it, please don't worry about it. You're going to get it in time. And you guys will have this lesson for later. And I hope that you guys will send these questions to your coaches. All right. All right. So number 20, what is the period of a trig function? 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 All right, Adam, do you know the answer to what is the period of a trig function?
I have no idea.
Great. That's why we're doing this. All right. Again, another very, very easy concept that you just need to learn. And the second that you learn it, you'll be able to do it forever. All right. The period of a trig function is the distance from hump to hump. All right. So it's just, you just figure out the distance from this hump to the next hump. And that is the period. All right. You could do it different ways. You could go from the bottom to the bottom. You could go from the middle to the middle. But it's just easiest in my mind, and we found it's easiest for most students, just the distance from hump to hump. The distance from hump to hump, that's all they mean when they say the period. All right? So very, very easy to remember and very, very easy to get correct. All right, so to be able to do this next part, you just have to memorize. There's no way to do it other than just to memorize it. It's kind of like memorizing the cosine of x and the sine of x graphs. But yeah, you just need to memorize. So I'm just going to give you guys the answers after I ask, though. I'm going to prompt your brain. So try to figure out what is the answer to what is the cosine of x? What is the period of the cosine of x? What is the period of the cosine of x? What is the period, the cosine of x? Just have to memorize it. Does anybody know the answer? What you got, Christian? 2 pi. All right. And the only way you know it is just by memorizing it. All right. So if you just memorize it, 2 pi, that is an easy point on the ACT, or at least the start of an easy point on the ACT. All right, it gets a little bit more complicated here in a second, but if you know the 2 pi part, that's the hardest part of being able to do these questions. It's the hardest part, being able to do these questions, okay? All right, so everybody try to figure out what is the period of sine of x. What is the period of sine of x? What is the period of sine of x? All right, anybody online know what the period of sine of x is? Nobody? All right, anybody other than Christian in here know the period? David? 2 pi. Yeah. All right, so they're both 2 pi. So yes, both cosine of x and sine of x, the distance from hump to hump on cosine of x and sine of x is 2 pi. All right. So very, very simple because they're the same. It helps. But all right, last but not least, tan of x. All right. What is the period of the tan of x? What is the period of the tan of x? All right. Anybody other than Christian and David? Wait. Pi. Yeah. So it's just pi. All right. So cosine and sine are 2 pi, and tangent is just pi. If you're not gonna, remember this, it's okay. This is a very rarely tested question. It's like 1 of every 5 ACTs test periods, and if you just know what a period is, you probably be able to get it correct on those. But this is, if you're trying to get in the upper 30s, this is when you need to know this type of stuff. Okay. All right. So last but not least, I'm going to just tell you guys that know how to do this stuff. Everybody try to find the period of number 24. Everybody try to find the period of number 24. Everybody try to find the period of number 24. This is the most advanced thing we'll do. Totally okay if you can't do it. But everybody try to find the period of number 24. All right, Enoch, any luck on this one? He needs some help. All right, so it's very easy. All you do is take the period of cosine. So what's the period of cosine? 2 pi. And then you divide it by what is being multiplied by the x. So what's being multiplied by the x? 3. So it's just 2 pi over 3. That's the period of that function. All right, so everybody can do this. It just, there's some steps involved. So sometimes it takes a second. But if they were to ask, this is a real question on an ACT, they're just going to say, what's the period of this function? It's just 2 pi divided by 3. It's a 5-second question, but you just need to know this little process. All right. So great work. You guys now how to know 80% of the trig questions on the ACT. All right. The other portion is what you guys learned this past week, the sine, cosine, tangent, being able to use that with the triangles, but with the sine, cosine, tangent, secant, cosecant, cotangent, and what we just learned here, that is 80% of the trigonometry tested on the ACT. So I hope you guys see you do not need to have had these classes to be able to get these questions correct. And we just learned almost all of trigonometry in an hour. You did not need to take a semester or a year to take that class in high school. And, some of you that haven't taken it yet are going to be at a great advantage because you really got the core of trigonometry right here. And you can fill in a lot of stuff way easier just from starting off with this little hack course on trigonometry. So hopefully you guys found that useful. All right. All right, does anybody have any questions on mind about any of this stuff before we go to the middle school math? Christian? It's 2 pi over 3. Does that make sense? Great. Elizabeth? No, it'd be 2 pi over 3. It really is that easy. It's so flipping easy. It's crazy. No, you're not doing any math. Simple, simple. Any other questions? All right, so let's go back to your schedule, and I want you to click on the Cliff Notes Retention Quiz. Cliff Notes Retention Quiz. We're just going to blow through as much of this as we can, and hopefully we'll be able to get through a lot of it, but you will be doing this quiz every day this week. Most of you will get to the point where you can do the entire quiz in 10 minutes or less. And that is, what we're going for here to get this foundational pre-algebra and algebra 1 stuff down. And remember, what the ACT loves to do on pre-algebra and algebra questions is to use letters instead of numbers to get you off your game, so that you don't know how to do it because you can't do it with the calculator. So we just got to relearn this stuff back to first principles. All right. So what is an integer? This is tested on 100% of ACTs. You must know this, and a lot of students don't, and that's okay. Yes, what is an integer? Parker, do you know definition of integer, or you need some help? Good job. It is a whole number. All right. Does it include negative numbers? It does. It does. Does it include 0? Yes. All right. So it includes 0. It includes negative numbers. It includes positive numbers. All whole numbers are integers. And you need to know that, or you're going to get tricked on the ACT. It is tested on, like I said, 100% of ACTs, or it is very rare for it to not be used somewhere on the ACT. All right, here's the next one. This is going to be one of the hardest ones on the whole quiz, and it is all you're doing is adding fractions. But because the ACT is going to give you letters instead of numbers, it's going to be very difficult for most of you to be able to solve this, even if you're really good at math. And once you get it down again, you'll see it's quite easy, but you're just not used to doing it without a calculator anymore. So everybody try to turn this into one fraction, x over y plus m over n. Try to turn it into one fraction. And if you can think back to how you're supposed to add fractions, if it was numbers, that might help you be able to do it here. All right, Hudson Harris, any luck on this one, or do you need some help?
Would it be x plus ym over yn?
Like that?
Yes, sir.
That is incorrect. That is incorrect. But great, try. I want to challenge you guys, to, if you are uncertain, I think this is a great practice in life. It is so rare. If you guys know anything about defending your thesis for your master's program, one of the most important things they are expecting you to say when you are defending your thesis is, I don't know. And most students, if they don't know that, will be so worried about saying, I don't know to something, but that is what they are testing for when you're defending your thesis. And I would love, if you guys take that away from this program to get more comfortable with saying, I don't know. If you don't know, it's okay to not know. That's one of the fastest way to get to know. So yes, I want to keep challenging you guys on that. If you're unsure, just say, I don't know. But Hudson, let's walk through this. All right. So let's just do the process with normal fractions and see if you can remember back to your little school days. So what would the first step be if we're adding these two fractions together? What's our first step here, Hudson?
You want to make the denominators the same number.
Okay. And so what can we use as a common denominator here?
6.
6. All right. And so what I want to challenge everybody for the rest of your math life, to make the rest of your math life easier, stop worrying about the lowest common denominator. You never really need that again in your math life unless that is actually what they're asking for, which is rare. For the rest of your math life, it is almost always easiest just to multiply the denominators together, and that will always work. It will always work. You can simplify it later on if you need to, but it will always work if you just multiply your denominators together. All right, so then how do we get the numerator on these new fractions after we've got a denominator here, Hudson? Do you remember that?
Yeah, you multiply whatever you multiply that fraction by the top number.
Well done. So what did we multiply 2 by to make it 3? Make it 6.
3.
Yeah, we multiplied it by 3. Therefore, we need to multiply our numerator by 3. So what is 3 times 1?
3.
3. All right. So what do we multiply 3 by to make it 6?
2.
2. So we need to multiply our numerator by 2. So what do we get when we do 2 times 2?
4.
4. All right. So what is our denominator going to be in our answer?
6.
6. So it's just going to stay the same. All right. You don't add the denominators together at this point. The denominator is just going to stay the common term. Okay. It's going to stay the common denominator. And so then what do we do with our numerators?
You add them together.
Adam. All right. So what's 3 plus 4?
7.
Great job. All right. So this is 7/6. So now let's try to follow this exact process with our letters. All right. So the first thing that you did in the other problem was to find a common denominator. All right. And how did I recommend that we always find our common denominators moving forward? Do you remember? Hudson,
Oh
or-
yeah, you multiply both the denominators.
Okay. So what do we get when we multiply y and n?
Yn.
All right. I do want to encourage you guys all to start alphabetizing your variables when you multiply them, because this is going to make it way easier to find like terms. It's a great habit to get in, and it'll help you eliminate simple errors in your math for the rest of your life. So if you alphabetize them, making this ny, it's just a great habit to get in for the rest of your math life. All right, so we've got ny as a common denominator. So how do we find our numerator, our new numerator? What did we do on the last one? What do we need to do to this one?
Would you multiply? Let me see the question again. Would you multiply x by n?
Yeah, so whatever you multiply the denominator by, you need to multiply the numerator by. So what did we multiply y by to make it ny?
Why you multiplied it by n?
N. So if we multiplied the denominator by n, we need to multiply our numerator by n. So what do we get when we multiply n times x?
Nx.
Nx. All right. And so what do we multiply ny to make it ny?
N.
Well, we multiplied n by y. Does that make sense?
Yeah.
Okay, so I'm just going to ask it again just so everybody's on the same page. What do we multiply n by to make it ny?
Oh, y.
Y. All right, so what do we need to multiply our numerator by?
Y.
Yeah, so what do we get when we multiply y times m?
Ym.
Yeah, or my. Just keep it in alphabetical order. All right, so what is the denominator in our answer going to be here?
Yn.
Yep, well, ny, just keep it in
Oh, yeah,
alphabetical
yeah.
order. Yes, can we combine nx plus my?
No.
No. All right, we cannot combine these, so they are just going to go, we're just going to put nx plus my, nx plus my. So this is our answer. Nx plus my over ny. Nx plus my over ny. And there is so much contained in this one question. All right, I know that this is hard for many students to conceptualize, but these steps are the foundational steps in so many ACT math questions. And so we're going to go ahead and do another one of these. We need you guys to get this. You're literally going to be doing this question every day this week. So we want to keep working on you being able to get these down. You need to be getting every question on this one correct. And this is the hardest probably of all the questions on it. All right, so I'm going to give you guys another one. We're going to do P over R plus S over Q. All right, everybody try it. P over R plus S over Q. P over R plus S over Q. Turn that into one fraction. Turn that into one fraction. All right, MJ Brooks, any luck on this one or you need some help?
Would it be PQ plus RS over QR?
That's it. All right, PQ plus RS over QR. Let's just walk through the steps for everybody. So how did you get your common denominator?
I multiplied Q by R and R by Q.
There it is. Yep. So remember, we're just going to multiply our denominators together. And then to be able to get our new numerators, you just have to multiply whatever you multiply the denominator by the numerator. So you get PQ for the top of that one. We multiplied this one by R. So we're going to multiply S by R. So we're going to get this on top. And then the denominator is going to stay the same, QR. And then it's going to be PQ plus RS. Awesome, awesome job. All right. If you're not getting it, it's okay. You're going to be able to practice this again and again, literally every day this week. You'll have a digital version of this quiz that you're going to be taking every day this week. And yeah, so you're going to be masters at this. Yeah. All right. So now this is going to start moving much quicker. You're going to learn a ton of math here. And if you miss any of it, it is okay. Like I said, you guys are going to be working on this all week, but I want to try to get you guys as much of this math as we can, as quickly as we can. So everybody try number 3. And yeah, I'm going to call on one of you. Let's work it down. All right, Cameron, Anthony, any luck on this one or you need some help?
I need some help.
All right. So when you're multiplying fractions, all you do is multiply straight across. So you're going to multiply your numerator times your numerator and your denominator times your denominator. So Cameron, what is X times M?
XM.
Yep. So we're going to do it alphabetical order, MX. And then what is Y times N?
YN. Or
Yep.
NY.
NY. And that's your answer. So
Okay.
Cameron, is that beyond your ability to be able to do?
Nope.
No, it's so easy, and you guys just need to brush up on this. All right. When you can't use your calculators, you guys become addicted to those. And this is how the ACT is going to get you. That's why we're going to use letters on most of this practice so that you get back to your basics. All right. Super simple. Everybody try number 4. Everybody try number 4. All right, Alex, any luck on number 4? You need some help. Say it again. XN over YM. Is that what you said? That's perfect. All right. So I'm going to teach you guys how to do this. All that you do when you're dealing with division and fractions is you flip the second fraction. When you flip the second fraction, it turns it into a multiplication problem. When you flip the second fraction, it turns it into a multiplication problem. And then you're doing the exact same thing that we did on the last one. Okay, you just flip the second problem and then it's a multiplication problem exactly like we did on the last one. Great job. All right, everybody try number 5. Everybody try number 5. This one's similar to number 2. You're probably going to have to think about it a little bit. Think of how we did that one. All right, Gage, any luck on this one, or do you need some help?
Is it RA plus SA over SA?
RA plus SA over SA. That one is incorrect. That one's incorrect. So let's work on it here. And we're just cleaning this stuff up. We're just cleaning this stuff up. All right. So what we recommend is if you're dealing with a fraction and a whole number, just turn the whole number into a fraction by putting it over 1. And then it's exactly like number 2. Okay. So with that in mind, what is our common denominator going to be here? And Gage, how do we find our common denominator?
You figure out like what it equals, like or like what the two rows equal.
Well, so you're just going to multiply the common. You're going to multiply the denominators together. So what are our denominators here?
S and 1.
All right. So what's S times 1?
S.
S. So S, just S by itself, is going to be our denominator here. Does that make sense?
Yeah.
So what did we multiply S by to make it S?
1.
1. So what do we need to multiply R by?
1.
All right. So that's just going to be R. All right. And so what do we multiply 1 by to make it S?
I'm sorry, what did you say?
What do we multiply 1 by to make it S?
Oh, S.
And so what do we need to multiply A by?
1.
Nope. If we multiply
Oh.
the denominator by S, we also need to multiply the numerator by S. Does that make sense?
Yes, sir.
So whatever you multiply the denominator by, you also have to multiply the numerator by. So what is S times A?
SA.
Yep, we're going to do it AS, just keep it in alphabetical order. And remember, our denominator is going to stay the same. It's going to be S. And can we combine R and AS?
No.
No. So our numerator is just going to be R plus AS. So it's R plus AS over S is going to be our answer. Does that make sense?
Yes, sir.
And do you see where you went wrong?
Yeah, I put A over A, and so that's where I went wrong.
Nope. And is this a useful tool? Just remember to always put it over 1 for anything to make it super simple.
For sure.
Good. All right. So let's keep rolling along. You guys are doing great. All right. Let's do number 6 here. Everybody try number 6. All right, Maria, any luck on this one? You need some help? Yep, we're going to do AR over S, just to keep practicing, always putting them in alphabetical order. But remember, we're just going to put it over 1. Since we got a fraction on one side, we want to turn the other side into a fraction by putting it over 1. And when we're multiplying fractions, we just multiply the numerators times the numerators, the denominators times the denominators. Super simple. Great job. All right, everybody try number 6. Everybody try number 6. All right, Jude, any luck on number 6 or you need some help? Oh, I'm sorry, number 7. It's not going to be AR over S. So do you remember what we recommended for number 4? What's the first step when we're dealing with division and fractions? It's okay. So we're just going to flip the second fraction. All right. So first we've got to turn it into a fraction. And the way we turn it into a fraction is by putting it over 1. So what does that fraction become when we flip it, Jude? Yeah, 1 over a. And so now it's a multiplication problem. And so when we're dealing with multiplication problems, how do we do multiplication of fractions? Or you need some help? Yeah, you multiply the top times tops and the bottom times the bottom. Numerator times the numerator, denominator times the denominator. So what's r times 1? And what's s times a? AS. And that's your answer. Does that make sense? Is that beyond your ability as a human to be able to do? You can absolutely do this. All of you can do this. You guys are just rusty or you're not used to seeing it when you can't do it with your calculator. All right. So we're going to keep moving along. All right. Solving in terms of x. This is tested on every single ACT. So I want you guys all to try number 8. Everybody try number 8. All right, Miguel, any luck on this one or you need some help? Great. All right. So what we want to do when we're solving in terms of a variable is we want to get rid of everything that's not that variable on that side. All right. So what's the only thing that we need to get rid of here, Miguel, to get x by itself? The 3. So what we're going to multiply it by is 1 or 3 over 1. Okay? Because if you have a 3 on top and a 3 on bottom, you can just cross those off. Does that make sense? And so if we do 3 over 1 on that side of the equation, we also have to multiply 3 over 1 on the other side of the equation. But do you see that that 3 over 1 allows us to just eliminate the 3 on top and bottom? Okay? And so now we just need to multiply 4y over 5z times 3 over 1. So what do we get when we multiply 4y over 5z times 3 over 1? It's not 15z. So you're close though. But remember, when we're multiplying fractions, you just multiply the numerator times the numerator and the denominator times the denominator. That's it. Does that make sense? So, but what I can guarantee you is that they're going to have one of the answers be 12y over 15z, because that's going to be a super common mistake. And so that's why it's so important to just brush up on all this stuff, because you guys have all learned this stuff at one point in your lives. Well, some of you didn't because of the COVID years, unfortunately, but you can all relearn this stuff really fast. And you will relearn all of middle school math this week in 1 week. In 1 week. All right. So don't get discouraged if you're having a hard time with this. That's awesome if you're having a hard time with this, because you got so many easy points coming on the ACT, because these types of things are integrated into every single ACT question. So you probably are doing all of the hardest steps correct, but missing one step in the process, like putting the 3 on both the bottom and the top, and you get it wrong, even though you did all the other steps correct. So we just got to clean this stuff up. All right. All right, everybody, try number 9. Try number 9. All right, Grace, any luck on number 9, or do you need some help with it?
Is it? Yeah, I don't know.
Totally okay. Totally okay. All right. So what we recommended before, we're going to recommend it all the time. If you're dealing with fractions, it's easiest just to turn everything into a fraction. So since one side of the fraction or one side of the equation is a fraction, we're just going to make this side of the equation a fraction as well, just to make it a little bit easier to deal with. All right. And so what's the only thing that we need to get rid of here to get x by itself, Olivia? I mean, Grace, I'm sorry.
The 3.
The 3. All right. So we are going to multiply this by 1 over 3. So we have a 3 in the numerator and a 3 in the denominator, and we can just cross them out. Does that make sense? So if we're going to multiply that side by 1 over 3, we also need to multiply this side by 1 over 3. And if we're going to multiply this side by 1 over 3, we're going to do 4y over 5z times 1 over 3. And what do we get when we do that, Grace?
4y over 15z.
That's it. When we're multiplying fractions, we just do the numerator times the numerator, the denominator times the denominator. And I hope you guys are seeing this pattern. This is why we teach this stuff in the order that we teach it. You're going to keep seeing the exact same things build on top of each other. And that's why it's considered foundational. They're just going to keep building. All of the questions on the ACT use these as their building blocks. And so you got to have these foundations down. But Grace, is that beyond your ability as a human to be able to do?
No, it's not.
No, all of you can do this, and all of you have learned how to do this. It's just been so long, and this is 25% of the test is directly questions like this, but nearly 100% of the test is built off of these foundational items. All right. So great work there. All right. We're going to spend we're going to try to make it through 10 through 14, and we're probably going to stop there. But that doesn't mean put things up. We still got about 10 more minutes. I want to look through this week and help you guys understand it. So please don't put your stuff away. We still got some more notes and whatnot to take. All right. So everybody try number 10. Everybody try number 10. No calculator. Do not use a calculator. All right, Charlie, any luck on number 10, or do you need some help with that one? Okay, so it's just saying, another way to write it is it's just -1 times -1. All right, so -1 times -1 is going to be +1. All right, but you just have to remember that if it's in parentheses, both of the things in the parentheses are going to carry that -1. All right, easy points. You just got to remember, if it's in the parentheses, you're doing -1 times -1. All right, everybody try number 11. Everybody try number 11. All right, David, do you know the answer to number 11, or you need some help? It is not just 1. It is -1, and this is how they're going to trick you on the ACT. All right, if it is not in parentheses, only the 1 has the square on it. The negative out front is like a coefficient. So it's essentially saying -1 times 1 squared. Another way to think about it, if it was -1a squared, you wouldn't do the -1 squared. You're just squaring the a there. All right, but it works the same way if it's on the 1. And the ACT loves to trick students with this one, because especially if you're using your calculator, a lot of students enter it in incorrectly in their calculator. and therefore they're going to get it wrong as well. But if it has the parentheses around it, it's saying -1 times -1. If it doesn't have the parentheses around it, you're doing -1 times 1 squared. So that comes out to -1. If that didn't make sense, it's okay. You guys have all week to learn this. And what I can assure you, it's right. You need to memorize those answers, but it'll click for you here shortly. All right. If you practice it enough anyways, and ask your coach when you guys are confused. All right. Number 12. Everybody try number 12. All right, Nick, any luck on number 12 or you need some help? All right. So this is going to be +1. +1. If you raise it to an even power, it's going to come out to positive. If you're raising it to an even power, it's going to come out positive. If you're raising it to an odd power, it's going to come out negative. So number 13 is going to be -1. All right. So if it's to an even power, it's +1. It's to an odd power, it's -1. Your negatives is one of the biggest areas where the ACT is going to try to trip you up on simple errors. All right. Is with these negatives. And this is one way that they get you with it. All right. Number 14. Everybody try number 14. All right, Ari, any luck on number 14 or you need some help? All right, it's -1. -1. Because no matter what, since it's not in parentheses, only the 1 is being raised to the 48th power, not the negative. All right, so no matter what, you're going to do the negative times 1 to the 48th power is essentially what it's saying there, which is going to come out to -1. All right, so hopefully you guys have seen that you have gaps in your middle school math, and this week is an opportunity to brush all that stuff up. And if your middle school math stuff is awesome, you're going to blow through this stuff and get to the much harder math or slash just the ACT math. All right. These questions are not going to be how things are going to look on the ACT. All right. But you need to get this stuff down so that you can get to the ACT questions. And all of the ACT questions use these as their building blocks to be able to trip you guys up. All right. So, all right. So now we're going to talk about a couple of things for this week. Like I said, we got more notes to take. Please do not put your stuff away. I want to remind you guys again, please go ahead and write down on your notes, actprep.com/mock ACT. actprep.com/mock ACT. actprep.com/mock ACT. All right. So our next one is on November 30th. And we want to make sure to get you guys in there. Go ahead and write down student, all lowercase. All right. You guys will get to attend that mock ACT for free using that code. So please remember to use that code when you are signing up for the mock ACT. It will be in this room here if you guys are attending in person, or you'll use the same Zoom link if you guys are attending via Zoom. Okay. All right. So as far as this week goes, I want you guys to just take a look at what this week is. So I'll have it on the screen. Hopefully you guys can see it. If you can't, you could just pull it up on your phone right now. But we're going to go to day 1. All right. So day 1 this week, just like always, you're going to start with your memorization. And something that is going to be a little bit different about your memorization this week is that it is okay to spend more than 30 minutes. You are able to use more than 30 minutes on your memorization this week and count it towards your hours, because the memorization this week is your formulas. So the lessons to teach you that are going to be much more like your lessons that you're going to be doing this week to learn the math. All right. And for so many of you, you're missing problems on the ACT just because you don't know the formula, don't know when to use the formula, or don't know how to use the formulas. And so this week is about learning those foundational formulas that show up regularly on the ACTs. And these are going to add easy points to your test. All right. And so, yes, I hope that you, will be very serious about this when you are doing the memorization. Obviously, try to be as efficient as you can, but it is okay for you to spend more than 30 minutes. Next, you're going to do your Cliff Notes Basics quiz. All right. That is the digital version of the quiz that we were just doing today, the middle school math quiz. It's going to be a digital version. You're going to take this every day this week, essentially. It'll be on your goals second. And tomorrow, you're probably all going to do really bad on it. You don't need to learn it before you take that quiz. It's just going to give you a benchmark of where you're at right now to let you know how far you need to go to be able to get that middle school math down. And it's going to find all of your gaps for you really quickly. Okay. Next thing, we're going to teach you guys how to use your cheat sheet and the 5-back system. Please do this lesson. You guys have not learned how to do the cheat sheet and the 5-back system if you just started the program. And if you did it on English, it's a good bit different on the math. So we want to make sure that you know how to do it. All right. Your worksheet that you used last week, that's for questions you miss on tests. Your cheat sheet is for questions that you miss on lessons. And most of what you're going to be doing this week will be lessons. All right. You guys are going to be doing lessons this week. So questions you miss on those lessons go on your cheat sheet. Every time you add a question to your cheat sheet, you want to master that question, go back 5. And that's what that cheat sheet lesson is going to teach you how to do, is get the most out of that. All right. And then the bulk of what you're going to be spending your time on every day this week is the mastery. All right. So I'm going to go ahead and click on the mastery so you guys understand how the mastery works. There are hundreds of lessons on the mastery. Hundreds of lessons. You're never going to finish all the lessons on the mastery. Your only goal each day is to make it as far as you can and pick up where you left off the day before. That's it. So you're just going to make it as far as you can in your 1.5 to 2 hours. And then you're done. When you get to 2 hours, stop. Or 1.5 hours, however many hours you're doing, stop at that point. You're done. And then the next day, when you get to the mastery, you're just going to pick back up where you left off the day before. All right? Some of you are going to jump around this week, and you're going to regret it. Do not jump around in the lessons this week. Just do the lessons in the order that they are listed as is explained on the instructions. If you jump around, you're going to regret it, and you're going to be confused. If you do it in the order that it's listed, it's going to be easy because everything teaches you how to do everything as you go. Next week, we'll jump around to the lessons that you most need to work on. We'll just laser focus right to the categories that you need to work on, that you're missing the most of on these tests. But this first week, we got to rebuild these foundations, and you've got to do it in the order that's listed because we're teaching you how to do everything as effectively as possible. Last but not least, please reach out to your coaches. Send your coaches screenshots if you guys are confused on how to do anything. Schedule Zoom meetings. You guys all get a 15-minute Zoom meeting with your coach each week, but you got to ask for it. You got to ask for it. All right. So, you got to get it before they fill up. So always best to ask sooner rather than later. Yeah. All right. So everybody go ahead and take a picture of your notes from the day. Text those to your coach, fill out your stats, and y'all are free to go. I'll stick around a little bit longer if anybody has any individual questions.